Start over. Okay, I know. That was crazy. So, numbers 1 through 5, rewriting 1 through 5 with a base of 3. So, 81 is 3 to the 4th. 3 is just 3 to the first power. 1/3 is 3 to the negative 1. 1 over 27 is 3 to the negative 3. And then the square root of 3 is 3 to the 1/2. And so, the property of equality, what that says is, if my bases are the same, then I can set my exponents equal to each other to solve for x. So on number 1, my bases are both 4, and so I'm going to say that x equals 2. Now it's not always that easy because the bases won't always be the same, and we're going to have to rewrite them to be the same. So my suggestion is making your bases, this is just a little hint or a trick, but make bases the smaller number. And so like on number 2, I have a 2 and I have a 4. Now I could make both of them be 4, or I could make both of them be 2. So it's easier to take the 4 and rewrite it as a base of 2 than it is to go from 2 to a 4. So if I decide, okay, I have a 2 and a 4, I want to make my bases 2. I'm going to leave this as 2 to the x, and I'm going to rewrite this 4 as 2 squared to the 6. So what I did is I rewrote 4 to be 2 squared, and it's still raised to the 6th power. Then I'm going to multiply my exponents. So 2 to the x equals 2 squared, or 2 to the 12th. So x equals 12. Now, you don't have to do this step right here. You can just skip it and go straight here if you want. In my head, I just know, I'm going to multiply the exponents. But if you need that second step, and it may take a little bit of practice, then you can do that as well. Now, sometimes for me, what I like to do is change both bases to have the same base. So 4 and 1/2 have what base in common? 2. So how can I rewrite 4 with a base of 2? 2 squared. And how can I write 1/2 with a base of 2? 2 to the what? Negative 1, right? So I'm going to rewrite this as 2 squared to the x equals 2 to the negative 1 to the 2x minus 3. So all I did is I replaced my 4 and my 1/2 with 2 squared and 2 to the negative 1. Now I'm going to multiply my exponents. So multiply these. So 2 to the 2x equals 2 to the negative 2x plus 3, because I'm going to distribute. Then you set exponents equal to each other. So 2x equals negative 2x plus 3. So x equals 3/4. Number 4, what base do 25 and the square root of 5 have in common? 5. So how do I rewrite 25 with the base of 5? 5 squared. How do I rewrite square root of 5? 5 to the 1/2. So then I will rewrite this as 5 squared to the x equals 5 to the 1/2, 6 minus 2x. Now, like I said, if you want, you can skip this step and just go straight to writing it after the multiplication. But I sometimes write it as 2 steps just to make sure that I don't make a mistake. So I multiply. So 5 to the 2x equals, I'm going to distribute the 1/2, 5 to the 3 minus x. Then I set my exponents equal to each other. So 2x equals 3 minus x. So x equals 1. Let's look at number 5. Looking at 9 and 27, what base do they have in common? 3? 3? You could not go from 27 to 9 without making it a fraction, like a 2/3 or something like that. So sometimes I take both of them and I lower them both to the smallest base. They both have a 3 in common, so I'm going to rewrite this as 3 squared and 3 cubed. So sometimes it requires you to change both bases, not just changing one of them. And more often times than not, it's going to make you change both of them to be the smallest base. So 3 to the 4x equals 3 to the 3x minus 3. Set them equal to each other. So x equals -3. Now, something that is helpful, not saying that this will happen, but if you have your calculator and this is on a calculator portion, then you can check your answer by plugging in, or rechecking, by plugging in -3 back into x. Now, most likely you'll get one of these on a non-calculator part, but for your homework you can. Number 6, what would I do with number 6? What's the common base? 10. So 100 I rewrite as 10 squared. 1,000 I rewrite as 10 cubed. Good. Multiply. Then set equal to each other and solve for x. Okay, so for number 5, I reduced them both to be a base of 3. Not number 5. We're doing 7 and 8. Number 7, I reduced to a base of 3. Remember, if you have a fraction, it becomes a negative exponent. And then number 8, reduced to a base of 2. Notice that I just went straight to the first, or I guess to the second step. I just knew I was going to multiply this by 3, and I was going to multiply this by 5. So I just went ahead and skipped a step. Okay, number 9, what is my common base there? 5. So 5 squared. So I'm just going to multiply the exponent by 2, so 20x plus 16. And 1 over 25 is 5 to the -3. So I'm going to take this, multiply it by -3. So -12x plus, not 12x, -12 plus 6x. And I set my exponents equal to each other. So x equals -2. So for number 10, make them both a base of 3. And you notice that you get this ugly fraction. When you set them equal to each other, You're going to add 1/2 x to each side. How did I get the 9/2? 4 can be rewritten as what? What the fraction? 8/2. And then if I add 1/2, so that becomes 9/2. And how did I get the 4/9? How did I get rid of the 9/2? Instead of dividing by 9/2, what's another way I can get rid of it? Multiply by 2/9. And 2/1 times 2/9, multiply across, becomes 4/9. Okay, for number 11 and 12, this is where the PEMDAS backwards comes into play. So I want to add and subtract. I want to get rid of the 1 first. I'm going to subtract 1 on each side. So -5, 2 to the 3x equals 3/8 minus 1. If I change this to have a denominator of 8, it would be minus 8/8. 3 minus 8 is what? -5. Now I want to move the -5 to the other side. Instead of dividing by 5, what could I multiply by? Like, what's the reciprocal of -5? 1/5, or -1/5. When I multiply across, the 5's end up canceling, and I get 2 to the 3x equals what? 1/8. This is now when I get my common base. So what is my common base here? What do they both have in common? A 2. So I already have 2 to the 3x. How could I rewrite 1/8 to be 2? 2 to the -3. Then I set my exponents equal. So 3x equals -3. So x equals -1. Number 12, PEMDAS backwards. So the stuff in parentheses goes last. So what do I need to do first? If I want to get rid of that 4/3, I do what? Multiply by 3/4. Good. And I get 11 to the 4x minus 3 plus 2 equals what? 3. The parentheses technically go away. Probably shouldn't have put them there. What do I do next? Subtract 2. 11 to the 4x minus 3 equals 1. Okay, this is interesting. What could I do? Any ideas? Any ideas here? What did you say, Claire? Set it up to 0. What does that mean? It sounds really good. If it's to the power of 0, it's 1. I'm so proud of you. Let's give you a round of applause. That's good. So, anytime you have a 1, this is like a special case. Anytime you have a 1 on a side, like on an equal side, you set base equal to the 0 power. So, I'm going to rewrite this as 11 4x minus 3 equals 11 to the 0 power, because that in turn becomes 1, right? As Claire so eloquently put. So it doesn't matter what my base is on the left or on the right. If I have a 1 on one of the sides, you make it that number and raise it to the 0 power. So then I set 4x minus 3 equal to 0. So x equals 3/4.